Not more than 25 years ago, HIV was a word that instilled fear, and it's a testament to the success of highly active antiretroviral therapy that nowadays we generally think of HIV as a manageable chronic disease. Unfortunately, the battle against HIV is not yet won, and while we can now manage the infection, we are still unable to completely eliminate the virus from the body and don't fully understand the effects of long-term infections. What we know for sure is that despite the decrease in mortality rates, patients living long-term with HIV are at a higher risk of developing medical conditions such as osteoporosis, liver and heart disease, and even cancer. There are now 35 million people living with HIV, and that's why it's important more than ever for us to find a cure. Researchers generally work on one of two approaches. The first is to find ways to use the body's own immune system to defeat the virus. The second, and what my project is focused on, is to find ways to make sure antiretroviral drugs work efficiently all throughout the body. Currently, antiretroviral drugs are very good at suppressing HIV replication in the blood, and that's because the drugs are designed to get into the blood very efficiently. However, there are areas in our body, such as the brain, that naturally limit certain drugs from entering. This makes it difficult for us to fully treat infections because the virus can infiltrate into all of our organs and tissues, but the drugs can't follow. And if the drugs can't get to where the virus is, it creates what we call a viral sanctuary site, where the virus is free to replicate and even develop drug resistance. Our lab and many others have studied how antiretroviral drugs get into the brain, but several recent studies have indicated that the testes could potentially be an important viral sanctuary site, harboring the virus and potentially contributing to sexual transmission. As part of my project, we have received access to rare human testicular samples from both uninfected and HIV-infected treated men. With these samples, we are looking for specialized proteins that help control drug transportation and processing, and depending on where we find these proteins, they can potentially have a significant impact on what drugs can and cannot get into the testicular tissue. Very few studies have investigated how drugs get into the testes, and our results are the first to offer a detailed roadmap of how drug molecules could get transported and processed in this tissue. Overall, our results show definitively that the testes are a complex pharmacological compartment that has the potential to limit antiretroviral drug concentrations. We hope that our study will guide clinicians in selecting drugs that penetrate into the testicular tissue more effectively and help contribute to the full elimination of the virus.